Hi students, this is Shivakrishna, Assistant Professor, Department of Civil Engineering in Anurag Engineering College. I would like to explain about the subject of pavement design. In this pavement design, we already know about the transportation engineering. In the transportation engineering, the road geometrics and type of the pavements and road intersections, it should be already studied in the previous semester. But in this fourth semester, I would like to introduce the new subject, that is pavement design. In this, pavement design means design of pavement. Design of pavement means you have to design the thickness of various number of layers. That layers should be totally depending upon the type of pavements. In this, pavements generally categorized into different types, that is involved such parameters. Those parameters are involved in that pavement. The thickness should be depending upon the such parameters. In this design pavement, the pavement should consist of determining the thickness of the total pavement or individual layers of the pavement in order to severe traffic for the anticipated design period. The design depend upon the various factors such as that are intensity of traffic wheel loads, load repetitions, temperature, rainfall, humidity, drainage conditions, frost conditions, and strength of subgrade soil condition, as well as materials using in that particular location. These all are totally depending upon the design of the pavement. In this pavement, in this first unit, total study about the various parameters involved in the design of pavements. First of all, we know what is the meaning of pavement. In this highway pavement, it is a structure. It is composite to superimposed layers of that materials above the subgrade soil condition, whose primary function is to distribute the applied vehicle loads to the subgrade. The pavement structure should able to provide surface anticipated rigid quality and skid resistance on that particular surface structure. Favorable light reflecting characteristics also we have considered in the pavement. Actually, the pavement should be consist of different types. What are the types means, that is totally depending upon the structural behavior of that particular pavement. In this, the pavement should be classified on the basis of structural performance. It should be categorized into three types. That is, first one flexible pavement, and second one rigid pavement, and the third one composite pavements. These three types of pavements are a very important role play in the transportation engineering. First of all, we are coming into flexible pavement. What is meant by flexible pavement? Flexible pavement, it is a combination of 4 to 5 layers constructed on in that totally differ with the surface codes of that material should be different from the other pavement materials. First of all, flexible pavements will transmit the wheel load stresses to the lower layers by grain to grain transfer through the points of contact in the granular structure. Why? Because this flexible structure should be consisting of or constructed with 4 to 5 layers. The wheel load acting on that pavement should be distributed to a wider area. The total wheel load should be acting in not a particular single point. It should be transferred through grain to grain, and it will occupy the place of wider place. Up to bottom layer, it will be decreases with increasing the depth of the pavement. Next point, Flexible payments normally has many layers. Hence, the design of the flexible payment uses the concept of layer system. Why? Because in this flexible payment should be consist of number of layers. These layers total payment structure in a number of layers. In the top layer, it is the best quality to sustain the maximum compressive stresses and strains on that particular road. In addition to wear and tear, the lower layers will experience lesser magnitude of the stress with compared to the surface layers. Low quality materials can be used in the remaining layers like bottommost layers. Next, flexible pavements are constructed with bituminous materials like bitumen, tar, and PMB. PMB means polymer modified bitumen. This is the structure of the flexible pavement. Here in this figure, we are seeing that 1, 2, 3, 4 layers are constructed in this figure that names as subgrade and subbase, base coats, surface coats, and wearing coats. In this surface layer, the total topmost material is very different with the other pavements. In the surface layer, it should be constructed with bituminous layer, so it is also called as bound layer. And remaining layers are constructed with granular materials like coarse aggregate, fine aggregate, and metals. So this is not binding with other materials, so this is called unbound layers. This load acting on that pavement, one wheel passing on the surface of the road, the load should be transferred to layer in this figure, and the load should be triangle shape. It will be occur on that particular granular to granular, the load should be distributed. And next one, see this figure, bottommost figure, typical cross section of the flexible pavement. Here the cross section of the flexible pavement, different names, it should be clearly visible on that presentation. What is that? Subgrade. That subgrade should be this total structure, the depth of the overall depth of this pavement should be provided up to 1 meter. This 1 meter should be divided into how many layers we are constructing in that particular location. It should be equally distributed to different such locations where the that soil condition is very poor. In that case, the thickness of the individual layer should be provided very high. Next, coming to rigid pavements. After completion of flexible pavement, we are coming to rigid pavements. What is the difference between the flexible and rigid? Flexible materials, it is bituminous materials, but in here rigid pavements are cement concrete materials. Rigid pavements have sufficient flexural stress. Here we are studying about the slab action. So slab action means CC concrete, plain cement concrete. That plain cement concrete, the behavior will be look like as a flexural strength. In this flexural strength, the transmit the wheel load stresses into wider area. So in this typical cross section of the rigid pavement compared to flexible pavement, rigid pavements are placed either directly on the prepared subgrade or any single layer like subbase or base coats only we here preferred on that particular location. These two layers only constructed in the rigid pavement. Directly the slab portion will be laying on that particular base coats or subbase coats. In this rigid pavement, load is distributed through slab action. In that one particular structure, in particular location, the slab action, how it will act as same look like only the rigid pavement, the slab action should be considered here. The pavement behave like it as elastic plate resting a viscous medium. And rigid pavements are constructed. What material if you have to use in here means Portland cement concrete, PCC. Unit weight of the PCC is 24 kilonewton per meter cube. It should be analyzed by the plate theory of layering theory. But flexible pavement, we are considering the layer system theory. In here only elastic theory like plastic theory, plate theory will be considered here. Assuming the elastic plate resting on the viscous foundation, plate theory, it is simplified version of layer theory, assumes that concrete slab, it will be acting on a one particular thickness. Bending of that slab due to wheel load and temperature variations, the resulting tensile and flexural stresses only affecting in this particular rigid pavement. This is the typical cross section of the rigid pavement. See here, only after subgrade we are consider only one particular layer, that is subbase or base coats. In the subbase or base coats, what is the depth of that here? 100 to 300. And what is the Portland cement thickness? Topmost layer of that thickness is 150 to 300 we should generally provide in the regular days. And coming to next one, composite pavement. It is a combination of, simply said that it is a combination of flexible and rigid. As simply as we are constructed in the number of layers like flexible pavement, but on that flexible pavement we are directly laying on the concrete material on the top surface, and on the above the top surface of the concrete material we have to prefer bituminous layer also. So that's why only two combinations it will be involved here, so that's why called it is composite pavements. This type of pavements will be preferred in the toll gates or footpaths and any pedestrian walkings. In that particular locations also we have to prefer the composite pavements. In this composite pavements, it is a type of pavement utilizes both asphalt and concrete materials. A concrete base layer provides structural capacity, while asphalt concrete layer wearing surface coats. In the design purpose, the wearing coats of the pavement is constructed by spreading bricks or precast regular cement concrete blocks like footpaths. We are generally seeing in the footpath roads, on the sideways of the roads, some of the precast blocks will be inserted on that particular location. That is also one of the composite pavement we look like as. But in this, joints should be there on that particular blocks. That joints should be filled with some sand material or filler material we have to consider. In that it possesses the dual properties and suitable for low volume village roads. We see generally in that particular location the pedestrians and the sidewalkers are very less compared to the flexible and rigid materials. In this pavements, what type of factors you should have to consider? Okay, and now coming to what are the factors affecting the pavement design. In this pavement design, these factors are very highly influenced on the particular road pavement. This figure is look like shown as the flexible pavement. In the weathering effects, it should be the road should be destroyed many several conditions. These parameters are very useful to consider in the design of the one particular pavement. What are the parameters here we are consider? First of all, wheel load and axial configuration, contact pressure, vehicle speed, repetition of loads, subgrade type, temperature, precipitation, traffic, etc. These are one by one we have to discuss in the next one. First of all, we are considering the wheel load. Wheel loads. The wheel load should be properly acting on that major role on the design of that pavement. This total wheel load considered, we are conducting different types of surveys. Based upon the surveys only, we are considering the total wheel load acting on that pavement. That load conditions we are considered in the and deciding the thickness of pavement, how much it should be provided on that particular location. Wheel load. First of all, consider the wheel load. Wheel load is an important factor to determine the thickness of the pavements. It should be adapted. By providing the adequate thickness, the load coming from wheels does not affect the subgrade soil. That's why only we are preferring the number of layers in the above subgrade soil. The wheel load acts at particular point on the pavement and it causes deformations. Generally, the wheel load should be very high acting on the pavement. Easily, the failures are occurring on that particular location. So, if the vehicle contains dual wheels, one side axle, axle means what? The connection between two tires, it is called axle. it is converted into equivalent single axle wheel load. Why? Because every vehicle should have consider tandem axle, multiple axles and single axle. That total axles we are different not count, but we are considering the one particular load, that is called single axle wheel load. That is, wheel load axle control the contact pressure within the limits. See, look like this figure. This is the structure and this is the a thick structure and a thin structure. Thick structure and thin structure both are same, but the load distribution on that particular location is very different. In the thin structure, the load should be not uniformly distributed, but in the thick structure, the load distributed uniformly in nature. Okay. Okay. Next, ESWL concept. ESWL means already said. What is that? Equivalent single axle wheel load. This wheel load, it should be converted into one single particular section. To carry a maximum load with a specified limit and to carry greater load, dual wheel or tandem axle loads, these total loads should be equivalent to one particular wheel load, that is called equivalent single axle wheel load. This single axle wheel load, this is equal to the stresses that occurring on that pavement. This is a semi-rational method. This is known as the scientist Boyd and Foster will be developed in this ESWL concept. Based on that names only, this concept will be called as ESWL concept. In this Boyd and Foster method, ESWL, two wheels it should be acting on the pavement. In this pavement, the load distribution, it will be triangle portion. In this triangle portion, linear, non-linear and elastic nature, that should be divided into three parameters, three different sections. In this developed expression, it should be used to find out the equivalent single axle wheel load. That equation is log base 10. P means the total load of the vehicle plus 0.3 log base 10 Z by D by 2. Z means desired depth, how much depth the load should be acting, and D means the depth of that total thickness, and by log 10 2s. S means spacing of that spacing between the wheels, and D means the distance between the first layer to top layers. Okay, these total parameters in this substituted in this equation, we have to getting in the equivalent single wheel load value. Okay, next coming to material characteristics. In that particular pavement, we have used different types of materials. That is also plays a very important role in that particular selection of the pavement. These materials following properties are both flexible and rigid pavements are very important. Why? Because in this every layer should have used different types of materials like granular materials, sub-base materials and surface materials. These are very different materials. That materials have to fulfill the strength and durability properties. So, when pavements are considered as a linear elastic, this elastic modulus and Poisson's ratio of the subgrade and each component layers must be specified here. Why? Because this Young's modulus and compressive strength of values both are plays a very important role in the thickness of the pavement due to occurring on the wheel loads. When a material is considered a non-linear elastic, the constitution equation relating to the resilient modulus, how much load acting on the pavement, how much expansion will be occur in that particular location, it should be definitely we are calculated. Okay, next coming to tire pressure. This tire pressure is very important. Why? Because the load should be acting on the pavement. The pressure should be developed between the surface of the road and surface of that tire. This pressure will be very important role. This tire pressure, the standard value should be given as though. As though means American Association State Highway Transport officials. These officials will give the some standard specifications. When we are designing the some of the particular thickness of the pavement, these parameters, these standard values you have to maintain particularly on the road geometrics. What are that values? As per the specifications, the tire pressure should be maintained in the range of 0.515 to 0.55 megapascal. and the tire pressure on the commercial vehicles 0.7 to 1 megapascal. The tire pressure is used to calculate the stresses induced in the pavement of the structure. It can be related to pavement damages. It should be the tire pressure will be increases automatically. The tire pressure will be the strength of that pavement should be decreases. Next, contact pressure. The contact pressure is the ratio of normal load to the true contact area, which is that sum of the front of rear and front areas. As the tire pressure increases, its contact area decreases, vice versa. But the load on the tire, the contact area also decreases. And next one very important factor, that is environmental and other factors. In this environmental and other factors, we are considered two important environmental factors should be considered, that is temperature and precipitation. This temperature affects on the asphalt pavement and concrete pavement are it plays a different role in the two different types of pavements. Temperature effects in the resilient modulus asphalt layers, while it indicates curling action should be acting on the concrete slab. Okay, in rigid pavements, due to difference of temperature top and bottom, the stresses will be changes. While means the compressive stresses will be changes to tensile stresses, and the tensile stresses it will be changes to compressive stresses. In this particular precipitation also rain and snow also very important role. In the cold regions, the precipitation or in rainy season, the many floods are occurred in that particular road stretch. So that's why the floods will be very high. The road should be destroyed frequently in that particular rainy season. So this much effects should be considered in the thickness of the pavements. You have to find out. These all factors should plays a very important role to find out the thickness of the layers. We have to maintain on the particular stage in that flexible pavement and rigid pavements. These total stresses and the total design of this individual layer should be calculated based on the Indian Road Congress specification guidelines as per IRC 37 for flexible pavement design and IRC 58 for rigid pavement design. These all are considered for the selection of the one pavement, and these factors are plays a very important role in the selection of the one particular pavement, either flexible or rigid pavement. Okay, thank you students, thank you very much.